So for this chapter, we've discovered many different ways of taking the integral of a function. Today, we'll get to learn another way. At the end of this video, you'll be able to evaluate an integral using something that's called the method of partial fractions. All right, the method of partial fractions is a method of decomposing a rational function into simpler functions so you can apply basic integration techniques. What we're going to do is turn our problem into a different problem, just kind of like what we did with trig substitution, where we're turning it into a different problem that we can work. And I'm going to jump right into the example to give you an idea of what kind of problem it's going to look like. All right, example 1 says to evaluate the integral of 1 over x squared minus 5x plus 6 dx. Now, if I were looking at this problem, I know I can't do a u substitution, but to me, it looks like an arctan problem. So that's how I would probably start the problem. This first part, please just watch. I just want to show you what doesn't work so we know that we're going to do something different instead. So if I were going to do this and I needed to complete the square, which is usually what we do for arctan, I would do 1 over, I'd make this x squared minus 5x plus a blank with a blank, and then plus 6 on the outside. And then if I completed the square, I'd divide by 2, which would be negative 5 halves, and then if I squared that, I'd get 5 fourths. So we would put plus 5 fourths on the inside, minus 5 fourths on the outside. And then, excuse me, when I did that, actually, did I do that incorrectly? Yes, I did. This would be 25 fourths. Sorry about that. So that would be 25 fourths. Okay, and then from here, I would have, this would simplify into 1 over x minus 5 halves squared, and then 6 minus 25 fourths would be negative 1/4. Okay, so it looks pretty similar to an arctan, but with an arctan I have a plus sign here. So arctan is out. We can't use arctan. So once again, I'm stuck. However, I notice that x squared minus 5x plus 6 can be factored. If the denominator can be factored, we are going to use the method of partial fractions. So I'm going to hop right into the steps to show you the process. All right, first step is to factor the denominator. So we're going to factor, we're going to have 1 over x squared minus 5x plus 6 would factor into x minus 3 times x minus 2. Okay, so that was the first step. We're now going to create separate fractions using a, b, and c. So basically what we're doing is coming up with two fractions that if I added together would give me this expression in step 1. So I'm going to have a over x minus 3 plus b over x minus 2. So that was my second step. And then my third step, and actually that equals 1 over x minus 3 times x minus 2. Okay, the next thing we're going to add the separate fractions by getting a common denominator. So the next thing that we're going to do is I'm going to just keep this left step how it was, and then it's going to equal, if I were to get a common denominator, this would be x minus 3 times x minus 2. I would have to multiply the top one by the x minus 2, and I'd have to multiply the second one by x minus 3. So I would get a times x minus 2 plus b times x minus 3. Okay, so far what we're trying to do is just create a problem that would give us this as an answer. Okay, step 4, set the numerators equal to each other. So on the left side, the numerator was 1. On the right side, the numerator was a times x, go back there a second, x minus 2 plus b times x minus 3. Okay, there are many different ways to do the next step of the problem. I have just come up with the easiest way, so hopefully, and there really is not a super big rhyme or reason to doing it this way. It was just a trick that seems to work, so that's what I'm going to do. All right, it says to evaluate the equation created in step 4 for different values of x. The values chosen will be x values that will make the denominator equal 0. Solve for a, b, c, whatever. So our next goal, we're going to try to find the a and try to find the b. The first thing that I'm going to do, I'm going to let x equal 2. And just watch when I let x equals 2 to see what happens. I'm going to have 1 equals. If I let x equal 2 up here, 2 minus 2 would be 0. 0 times a is 0. When I let x be 2 in the second one, I'm going to get negative b. So notice what that allowed me to do was to solve for b. So now my b is going to equal negative 1. And again, that's just a trick that works. there's a process that's quite a bit longer that works as well, but I figured we would want the faster one. All right, now this time we're going to let x equals 3, because notice again that's going to make one of my parts in the parentheses turn to 0. So when I let x equals 3, I'm going to get 1 equals, and the 1 just came from the left side of the equation. When I plug 3 in for my x, I'm going to get 3 minus 2, which is 1, times a is just going to be a. And then when I put 3 in for the x up here, 3 minus 3 is 0, times b is just still 0. So I basically just found that a is equal to 1. So I found my a value and I found my b value. Now my next step, it says to rewrite your separated fractions, replacing a, b, and c with their values. So if you recall, we had a over x minus 2 plus, actually I think we had a over x minus 3 over b over x minus 2. And so now what I'm going to do is just replace my a. I found out that a was 1, and I found out that b was negative 1. Okay, and then once we did that, basically my original problem looked like this. Okay, this is the equivalent. So if I were to get a common denominator for this and combine like terms, I would end up with this as an answer. So what we did, we just pulled it apart. So now, since there's a plus sign, I can take the integral of each part separately. And I notice for these ones, since I do have du over u, this would just end up being natural log. So this is going to be the natural log of x minus 3. And then this minus sign is just going to pop out front. And then minus the natural log of x minus 2. And then since there's a minus sign in between the natural logs, we can finish this up by turning it into a division problem. So I'm going to have the natural log of x minus 3 over x minus 2 plus c. And that is my answer. So now hopefully you're a little bit familiar with the method of partial fractions.